Hello there. I'm not happy with this bloody antenna. It's not performing as I would expect, and the SWR is just awful. It's probably around 3 or 4 to 1 SWR. Well, that's no good at all, is it? Not only is it a bad power match, it could possibly damage the radio I've got it connected to. So I suspected that balun, made out of Chinese semi-rigid coax, was possibly the problem. So I tried to find a source of the one they specify, which is, what is it? It's called UT141 anyway. UT141 it's called. And I had a look around on the internet, and there was a company in Europe would sell me 3 meters at a cost of £22.50. So, and then there'd be VAT on top of that. That would have been up to about 27. Then there would have been postage, and it would have ended up costing me about £35. So after that I thought, no way, I'm not spending all that. And it may not even improve it, even if I do use different semi-rigid coax. So I looked on eBay, and I found this stuff, and this is what I got. It's was described as new old stock, 3 meters of UT141, as it says there. And it's he wanted £15, which is not a bad price really, or best offer. So, well, I thought I'd offer him 10, see what happened. And he countered my offer with an offer of £13.50. So I thought, fine, yeah, I'm not going to quibble over a few pound. It might be worth it, even if it doesn't make any difference. Making the balun with the stuff, I'll probably use it at some point for something else. So let's take it out of its packet. Right, so you can see what it looks like. It's fairly stiff, but obviously it can be bent, but you've got to be careful not to try and bend at too sharp an angle, otherwise you kink it. And inside you've got PTFE insulation with silver plated inner conductor. And this stuff's usually used at microwave frequencies because it's very low loss, and it's also easy to bend to route it around whatever you're doing. And many years ago I used to work for a government organisation, and I had a job of wiring up this chassis with this stuff, and it was for a microwave aerial working on about 10 gigahertz, I think, from my memory is a bit hazy now after all these years. And my job was to wire up all these amplifier blocks, low noise amplifiers and switches and relays or whatever on this chassis. I quite enjoyed doing that. It was quite a bit like plumbing really. You know, you've got to get all the dimensions correct and all the angles right, otherwise it doesn't fit and you have to start again. Of course I had the right kit to do it, which is enormously expensive. You've got bending jigs and bending wheels for different radiuses, and also cutting tools to give you a nice clean edge when you cut it. But I can do all that fairly easily, and without that kit. So what I'm going to do is I'm going to take the old balun off, and the old driven element with balun attached, and that's fairly easy because it will just slide over all the directors. So I'll just go ahead and do that. Okay, so I've got the driven element off, and I've got to get the balun off, and I think I'm just gonna cut where it joins to the driven element. so I can desolder that later. Now I've got to heat it all up with the Weller with the big bit on it. I have several Weller soldering irons, some with small bits, some with big bits for doing jobs like this, and it will easily cope with heating this up. It just takes a long time. It just takes a long time. And it takes such a long time that I think I'm going to pause for a second till it starts warming up. Okay, well, one side's gone. Oh, then yeah, the other bit's fallen off as well. Didn't quite manage to capture it all on camera, but it wasn't very exciting. So I think what I'd do is just knock off some of the solder. Yep, I've got to wait for it to cool down. And while I'm waiting for it to cool down, I can first of all get rid of that inner stuck on there. Oh, the whole thing's fallen off, never mind. And take that bit off there. Right, got it. I've got the inners off that I cut off earlier. Yeah, while I'm waiting for it to cool down, I can make my balun, my new balun. So, see if we can do that then. Okay, so I've got my semi-rigid coax, and the balun from there to there, 39mm. So, what I'll do is multiply that by 2 to produce 80. Then we've got the inners on the end, so 80. I'll make it 90. I'll make it 90 total, and then I can cut it down from that. After all, I've got plenty of it if I go wrong. So I'll use roughly 90. Roughly 90. And to cut it, I will use this saw which belonged to my dad. He was a watchmaker and he always called it a piercing saw. So he used to have to cut bits of brass or whatever for watches when he was repairing them, and I inherited it, and it's a very useful saw. So I can do that by hand probably without putting it in the vise. Just do the first bit by hand and I'll put it in the vise for the accurate when I've got it, when it needs to be more accurate. Alright, done that. So what have we got? 90 something, 95, that'll do. Okay. Now, what I'll do is I'll mark it halfway along. 90, so that's 92. 90, it's near enough 90. So that's 45. And I'll bend it at that point. Now it says the inner dimension should be 11mm, but I don't think that's critical. But what I'll do is I'll just bend it around a drill. Hang on while I look for a drill. Okay, I found a 9mm drill. I'm just going to try and bend it and keeping the centre centered, which it isn't quite, but never mind. Oh dear, well never mind. Let's see what we've got then. 39 it should be, and I've got 40, 43 and allowing for the yeah, I think it'll be alright. I think it'll be fine. It's just about cooled down. goes on there. I think I'm going to have to do the rest of this off camera, it's just too hard, but I'm sure it'll come out fine. So yeah, I'll do that. Right, this is the completed balun, and I've bent the inners up so they will solder onto this bit here, so it goes like that basically, and looks about equal both sides. Yeah, that is pretty bloody close to 39mm. Closest I'm going to get it, it's within 0.2mm. So next job is I'm going to solder it in place. I'm going to do that off camera as well. Right, I'm going to try and do this on camera, or some of it. First of all, I've got to put a bit of blob of solder on the inner. That's what I solder first, and that will stabilise the whole thing. Right, okay, and the other one is supposed to be 9mm, I think, from the centre. Which it is. Right, I'll go at this one. Fine, I've got that. I need to cut that little bit off, and now I've got to solder the outer to the socket, so I'm just going to heat it up off camera. Right, I've got it in a little vise with rotten old cloth insulating it heat wise from the metal of the vise, and its solder's just starting to melt. That's that side done. I wouldn't have been doing this yesterday. It was about well over 33 degrees here yesterday, and records were broken for the hottest July temperature ever recorded. I think it was about 30, nearly 39, 38 point something, not sure exactly, which is about just over 100, I think, 100 Fahrenheit. Anyway, at least it's a lot cooler. It's down to about 75 today, and much more comfortable, and the humidity's dropped as well, which is good, and that, I think, is good. All done. Just wait for the bloody thing to cool down, and I'll reinstall it. And if this doesn't work, well, I shall jump up and down on it and smash it. I mean the whole antenna, because I can't see what I've done wrong. I've followed all these dimensions absolutely perfectly, but what I have found is another article by the original guy who made the antenna, DL something or other, German, and his dimensions on that are completely different, well, within a few millimeters. So perhaps I should have followed that one in the first place. because this seems to be a later modified design by some English guy. So, but that would mean buying more aluminium, which I don't really want to do, unless I can pull their rods out of the boom and drill more holes in different places. But that might be difficult. Anyway, this thing is still red hot, so I'm gonna... Okay, so what am I doing? I've got the return loss bridge connected up to the spectrum analyzer, and I've got this short cable which I've normalised out, so when I connect it to the antenna it will give me a return loss reading in theory. So I just do that. Okay, well that's bloody awful, isn't it? So I didn't make the slightest difference. I move the antenna where there's less metal. It's still fairly awful. It's probably about the same as it was before, basically. So that didn't make any difference whatsoever. So I question that design and the dimensions. So next thing to do with it is smash it up. Maybe not. Yeah, I don't know what else I can do with it. Try and rebuild it with that other design. I mean, it has got a sort of a resonance around there. That's 1251, and that's quite a good return loss. That would be about 1.3 to 1, something like that. That's not much good if you want it to work at 12, what was it, 1296. 1296. Yeah. So in theory, if you made the elements a bit shorter, it might come up, but who knows? I think I'd rather stick to the second design and try and decide if I want to buy any more aluminium to make it. Okay, not a very successful video, but it was worth trying, and at least I've got some decent quality semi-rigid coax. Anyway, bye for now.